Hello. It is time. I think Spotify is really quiet. I don't know why, but it is very quiet for some reason. I don't know what's up with that. Normally the volume I have it at is like just a little bit below what I would have it during the starting soon screen, and then I turn it down like a little bit. But I have to put it like higher than the starting now. I don't know why. Oh, thanks for following. Pawn. I just started. Interesting timing. I haven't even had my stuff set up yet. I forgot. Okay. So I was dreaming about this. I figured out why. So if I'm rotating about my up axis for yaw, as soon as I pitch down, my yaw is now going to actually increase my pitch. So that's why it was dipping down early. I guess it was supposed to be going up, or I don't know which. Either way, it's like some kind of gyroscope thing. Dream coding is best, yeah. So I think what I have to do is I have to rotate about my ground normal axis, whatever that means, and pitch can stay the same. But because the yaw affects the orientation of my rotation, my pitch affects the orientation of my yaw axis. I have to do yaw some other way. Okay. So I think roll and pitch can all go together, but then I have to do yaw in a bit different way. So what I think I need to do is I can take my ground normal, cross with my forward, and that gets me, I guess, the opposite of my forward. And that gets me a right act. Okay, so here's the idea. I have to construct a new basis vector. Basis, not vector, just basis. Where my forward and my right are the same. I guess I say my forward and my right. My right is the same. My up is the ground normal, and my forward just has to be fixed to whatever that is. So I need a new forward. So yeah, I take my current forward, the up that I want to have, and okay, no, I don't need that because I already have the right. So I have the right axis that I want. I cross that with my up. Right. That actually gives me a forward. So must fix yaw. There's no am split on the right. That word I never get right. Yeah, okay. Independent of the current pitch. Song sounds like RE Save Room. This is from Hollow Knight Silk Song. Can I just not even make a basis? Is there a way that I can... There probably is, I don't know. I'm just gonna go with it. So I take my right, cross my forward, or cross, I take my right. Cross my up and I get like an opposite forward, essentially. And this is backwards, I think. Right, cross with up, step forward. I flip it to make it front facing. Am I thinking about that? Wait. Ah, no. It is the right way, actually. I'm doing the hand thing wrong. Right, up, forward. So it's already good. And there's a case where this comes out to be 0, so then I'm just gonna do angular. I'm just gonna leave it. Otherwise, I have a leveled forward, so now I should be able to say angular add. I can just make the basis now because I have the vectors. I have maybe that's it. Also, this is definitely too high. So I think the right thing to do is to actually multiply this by some value. Maybe I'll do like 1.5. And I'm going to drop this to be low. Or lower. Okay. So turn around and don't do the crazy stuff. Okay. We got there. So maybe I don't quite do... You doing procedural movement? I am. The legs are weird right now because the green areas don't turn with it for some reason. Which I'll figure that out. Okay. Let me try... I also had a thought of doing rotation acceleration up here. I don't think that changes anything, to be honest. I think that should do nothing different. Maybe it will. Maybe it'll be crazy. No, it's still really slow to reach me, actually. Looks nice. It does walk, but I've turned off the walking, so it only turns right now. Why does it do this though? Alright, but I got the pitch fixed. So I guess... it looks like that's working. Now let me go to 90. I feel like this value should be something. I feel like I should have a value there, because that seems to actually make it speed up, but then it does this overshoot. Maybe I allow it to overshoot. How does move toward work? Whoops. Maybe I should allow it to overshoot. Probably not a good idea. It could be really bad. I feel like this might be too loud. Yeah. Really. Delta, length, if length is less than delta. What? Oh, this is super weird. I just saw this, and my first thought was, so this function returns true, but this is C, this is not Python, or JavaScript or whatever. If the length is less than the delta, or the length is very, very small, return... What? The delta... If the length is less than delta... Right. Otherwise I return that plus the delta over the length times delta. Which one of these happens first? This one's supposed to happen. No, this... This is a terrible function. This is just so compressed. Okay, well, what I want to see then is this one. Vector, because he literally has a move towards, which I want to see if that, and then crazy Kotlin where you just have some of your vector methods defined here, just some of them. That's insane to me. Wait a second, maths here or maths? Yeah, that's organization right there. Move towards... Oh, it's the exact same thing. It doesn't overshoot. Wait, no, this is... What is happening? Right, Kotlin is like an alien language, I guess. I've never seen... I didn't know you could do this. And also, it's vector move towards and vector 3 move towards. What is vector then? What's a vector? Bucket vector. Okay. I get it. Is this repo you're using to learn from? Procedural creatures? Yeah, there's this... I feel like this was a pretty popular video for a while because I wasn't even like looking for this. It just showed up. There's like 1.5 million views. So yeah, this is the source code for this. And I'm just looking at what he does for rotation because he does something with the rotation that's actually sort of that I can use. Because I have to work with angular velocities. I can't work with rotations. So that's part of it. I just want to know if it's the same thing, because it looks like this is the same thing. This add multiply speed over distance. Like that's exactly the same thing that's written here. This add is that the same? So there's delta. Delta multiplied by speed over distance. Is that the same thing? Delta... I mean, it is speed multiplied by speed divided by distance, and distance is length. Yeah, okay, it's the same thing. The thing that's getting to me is that mine looks different. Mine is really slow, and it doesn't overshoot quite the same way. Oh, what? I'm in the wrong. In his example, his like rotates kind of snappy, and maybe it overshoots a little bit. So unless he's got really, really high values, I've done something wrong, I think. Could the values be a bit different? That's what I think. There's this gate rotation lerp, which I feel like must be either some large value or some really small value. And then I have this rotation acceleration, which must be a very high value. So they're both in gate. That is so small. Rotate acceleration 0.2. Oh, that's galloping though. What is a default? Rotation lip is 0.3. Rotation acceleration. 0.15 over 4? What? That. His is way smaller. And then he has this interpolation, which essentially just means we take the difference and we reduce the value. Which I don't know why you would do that. You could just multiply it by that value. This is kind of like a silly way to do that. It definitely couldn't be degrees, because that'd be just such a small value. 0.05 degrees per second, that's way too small. It must be radians. And he's using pi, so it's obviously radians. This, I don't know what this does. What does multiplying a quaternion do? Composes two quaternions. This rotates the right by this one. Okay. So we take the difference, we rotate it by orientation, and then we take that. Then we take the opposite of my rotation and rotate it. I mean, sure. So it's just getting a difference. It is just getting a difference. 100%. I don't understand. These are such small values. Maybe that's what I should do. Maybe I actually just need a smaller value. What if I tried his? This was like times 0.3. That's what I'm thinking this does. It essentially takes the difference and interpolates it towards 0. Multiplies it by 0.3. And this rotation acceleration is like a tenth of what I'm using. So I'll just type in 3 or 5 or something. What's close to that? 2. 2 is close to that. An acceleration of 2 degrees per second. I feel like it's just never gonna reach me. It's just never gonna turn. Yeah, that's like, I don't know what I'm missing. This is where he does the rotation.
Another issue is that the legs will phase through each other if the rotation changes. Next,
look how
we
quick
can
this
tell the
is.
spider to stop moving if its legs get too far away from.
I mean, maybe... Okay, maybe this is old code. Maybe this was old code because there is this up here. think this is where he actually does rotation. Or
Hi,
he
welcome to the...
does a little bit more of rotation.
Now that the spider has a visible body, it looks odd that it can only rotate on one axis. To support 3 degrees of rotation, I rewrote the plugin using quaternions, as they tend to be easier to work with than Euler angles. To calculate the target orientation, I take the vector between the front and back legs and use it to calculate the pitch. Likewise, I take the vector between the left and right pairs and use that for the roll. I give the spider about 30 degrees of leeway so it can look at the player or at the laser.
Like, look how fast this is. I don't know what
I
I'm doing
considered
wrong.
rotating the scan bars as well so it could scale steep terrain, but this feature still needs quite a bit more work. I've disabled it in the meantime, but you can re-enable it in the settings if you want to try it out.
Yeah, at one point it just walks through the whole thing.
Next, I wanted the spider's body to rotate when struck by a trident, so I implemented angular velocity.
Also, the other thing that bothers me is that his legs are coded a lot simpler than mine, and they step in sequence every time. I don't know what I did. I mean, I guess I know what I did. I have...
In the process of adding this
The
feature,
legs are not
I accidentally
totally
created
aligned
a
the
subtle
same way.
spring effect when the spider rotates. I decided to keep it, and you can exaggerate or dampen the effect by tuning the parameters.
Either these values aren't the same 4 months ago. I mean, they must be. Like... Wait, where does it? Options, walk gate. Options, hexbot 4. Presets, hexbot. Chances could be that device work for Minecraft's engine, but not Godot. If it's radians and that's it, then they should be the same. If I have a body rotate at 1 radian per second, that's going to look the same in Minecraft or Godot. There is this, where technically I should be... If I wanted to do it really accurately, I would use this inertia thing, because it should rotate slower on certain axes, or rotate faster on other axes. But if I just don't account for that, then the mass doesn't matter. The mass of the object doesn't matter. This is rotating like 5 times the value we saw. I don't have any angular damping. I definitely don't, because if I were to just do... Yeah, so it just uses default options. If I can find those. Gate default walk, gate default gallop. Default walk, 0.15, which just uses these really small values. Like, unless his math with quaternions was like kind of wrong and it gives like an extreme rotation value or something. I mean, okay, so there's also this. There is technically this. I believe that due to states, this is something that he doesn't actually have. His runs every tick, which is why he probably has really small values. But if I were to use those small values, and then multiply this by 60, maybe this looks the same. No, it's still just really slow. Also, what is this printing I have? The pitch has been fixed. There's no way this can be... Is that actually the other way around? I still think this value has to be over 1, or there's no way it could ever... overshoot. Yeah, it'll like always undershoot slightly and take a long... and also just never reach it. So I think no matter what, I need something here for this. So let's just multiply that by 60. To 20, in fact. So at least 1, and then I'll let this be like probably up to 10. Maybe that seems right. I wonder if I could also actually square it. What is... Okay, well I can't exactly square it because then it would be negative. But sine times... what does that look like? Wait. No, because I'm getting the x... Yeah, I shouldn't square it because it makes small rotations really small. But it does make large rotations really large. Love this site. I use this almost daily. I mean, I guess I can scale the whole thing by pi. No. I have to write it in both cases. Okay. So it's smaller when it's, I mean, less than 1. But in terms of like degrees, what would that be? When it's below 50 degrees, it's a smaller rotation. I'll start with 5. I think I need this at the minimum. You ever look at Graph Toy? Nope. I just use Desmos because that's the only one I really know. I know there's GeoGebra, but I can't use that. Every time I try to use it, I struggle to do very simple things, and then I end up deleting my graph or my equation by accident, and then I can't undo to get it back. Something like that. Like I'm trying to do like some visual graphing, and then I mess it up. All right, so I think let me actually do let me just try this. Why don't you like that? Oh, because angular is a vector. You have to let you see the outcomes of the values moving if you want. Whoa. Why are we so slow? I mean, I've set up Desmos to do stuff like that. Like I can put in a point and I can drag the point left and right and see what the output is. Two. It's not facing me. And it's probably never going to face me. Okay, so what is this? Why does this happen? Why won't you look at me? Yeah, it's really struggling to look at me. Okay. So it probably... Alright, so it's probably not good because then the small values get really small and they get really small very fast. Yeah, he like comes to a stop. Alright. Can't do that. If I remember correct, you just add t for time in the equation. Oh, that's neat. Alright, so 3 was too much. But also weird that it was too much. I feel like it shouldn't have been too much. What? Like, this is what I don't like. I don't want to keep tuning these parameters like this. This is the wrong way to go. Because then the other thought is, okay, well, this should be lower, right? And now maybe it will actually reach me a bit faster. It'll keep that speed and then overshoot more. Yeah. So... I just don't know why his code works, because there's also this part. The fact is that he reduces his difference. And somehow that still reaches the desired orientation. I could do this. I could take my current orientation and no, I can't. Mine works. Is it something like this? If we're greater than pi... Oh, because that doesn't make any sense, because if you're rotating about the y-axis, why would you want to rotate more than 180 degrees? That's just correcting it. It doesn't make any sense. And the comment convert to pre-multiplied doesn't sound right. It doesn't sound right. What does pre-multiplied mean? Because I think of that being the result is pre-multiplied by some factor. What I think he means is that he doesn't mean pre-multiplied at all. He just means we're multiplying the orientations together to get the difference as a quaternion. And then we convert it back to Euler, which is kind of weird. But I guess this makes it so that it's a smooth interpolation instead of doing any weird like flips and things. I don't know, what if I went even higher? Whoop. It's this slowdown at the end that I really just don't like. I just wish it wouldn't do that. I just wish it wouldn't do that. I can make it be... Okay, here's what I could do. Yeah, I can do like the other one where if I have a rotational velocity, it needs to be at least like some minimum rotation speed. So if I have a target that I want to go to, I need to have some minimum. And then I would just have, but then rotation overshoot is not the value anymore. Yeah. I think what I mean is that angular should be some minimum value such that it will be at least a change of 2 degrees per second or something. Or maybe yeah, let me say 10 radians as degrees, same suffix. I'll start with 2. Minimum rotational speed to reach when turning. Reduces long tail of rotation. I don't know. I sort of have this somewhere for legs where the legs need to move some minimum amount. But then if I do that, I also have to make sure that I'm not crossing. So I want to do the minimum amount, or I want to do whatever is going to rotate me to my target and not any further than that. So if I'm rotating, if I have, okay, let me just think about it in a single take. If I have to go, if my minimum rotation is what is it? 1 degree, and I have to go half a degree, what does that math mean? I can think of it like moving on a line, I guess. So I either need to go yeah, okay. Let me just say and it should be kind of like a min and then a max. And the minimum is going to be whatever I might I guess it's to cover the full rotation in this step. So it'd be like oh jeez. This math is always, I can't visualize it well, but I get it right. And then I don't understand why. I don't know, it's been like Alright, let me look at this. Let me look at a part that I know is written correctly. Here it is. Here it is. So the stop length is either my deceleration or this max stop speed, which is my ground speed over step. Which is easier to think about because it's just preventing me from reversing direction. But here, it's more preventing me from rotating further than I mean to. Alright, the max part should be simple. Angular X or I guess the rotation minimum rate. So these ones should be easy. Where is it? That's not easy. Let me ask what Linux you use. I'm trying to decide on a Linux to use for game development. I use UE, Unity, and Godot depending on my contracts. Looking at Pop, seeing if there's anything else. All I use is Godot, and it works well for any Linux. I'm using Arch, so it's really... If you're going to be using other software, like UE and Unity, I would probably say to use, like, a proper... I guess like friendlier Linux, so probably Pop is good. I just use this because I know that I don't want to use software that doesn't work on it, if that makes sense. If it doesn't work on a less set up version of Linux, then I don't want to use it. Okay, so if it's the larger value between angular and minimum rotation rate, or if my angular difference... Actually, you know what? It might be the issue. It probably is the step thing. Because it's, yeah, okay, so this should fix it. Essentially, this just, what this means here is that no matter what angle I have to reach, I will always take a second to reach that. And because I don't amplify this value, if I don't amplify it by anything, it should never reach it. It's always like, oh yeah, we have a ½ degree to go, let's take a second to get there. And then the very next take it says, oh, we have 0.5 degrees to, or we have 0.4 degrees to go. All right, let's take a second to get there. We have 0.1 degrees to go. Let's take a second to get there. That's actually exactly why I would need a larger value than 1 here. But I do want to make sure that doesn't overshoot. I used Arch, Kali, Mint, and Cinnamon in the past. If I was only using one, I would probably go back to Arch, but family wants to use a computer once in a while. I mean, Arch can work. I think no one would really have a problem using my computer. They just have to like know how to go to like different windows or different desktops, I guess. Like, at least on Windows, though, it seems like there's a lot of vendor lock-in that they try to do with you. I mean, it really is. I mean, honestly, that's kind of seems like that's where their strategy is at this point. They want to make it so difficult to use anything other than Windows, so that you can't, because it's too hard. They want you to use all their software, their internet browser, everything. And they really... Installing apps is like always through the Windows Store, like anything. There's like backdoors in the Windows Store, so... there's weird stuff. But then it also causes glitches. I've like reinstalled Windows a couple times, and every time after like 6 months there's just glitches that start happening where software can't update. I can't log in to Minecraft, or Minecraft just takes a really long time to load. There's stuff like that, which is just loading the login screen. I'll keep it in mind. Might bring me back to Arch. I mean, I like it just because I went to Linux because I really hated Windows. I was really sick of it. The constant problems I was having. I just couldn't use the computer. And I was like, you know what? I don't care how long it takes me. I'm just going to use Linux now. And if I like am missing anything, like whatever I'm missing, whatever's not working, I'm just going to make it work. And so far, I have not had a problem I couldn't fix. Or something that I'm missing that I can't get. One thing that makes me really mad about Windows, especially with Minecraft, is that their default launcher hardly functions on Linux. So I use Prism, because Prism actually loads in less than a minute. And the Minecraft launcher takes like a minute to load the login button, and then you click login, and then it takes another minute to load the play button. I don't know what they're doing. So much use of stuff stored and is never deleted unless you know how to do it yourself. There's also that I found that there was like a terabyte memory swap file or whatever on my hard drive that Windows created. Like I did a bunch of like disk cleaning, like just deleting files, and I was like, I just cannot figure out where a terabyte of data is just taken away from me right now. And apparently somehow, some way, a terabyte hidden file was buried somewhere in my hard drive. And it was specifically a Windows thing. It was like a Windows memory management thing. Yeah. Oh, what is this? What is this? What is this? I guess I mean, I could say Angular over Step, but that doesn't seem right. It has to be Angular something. Oh, because Angular could be like a really tiny value. No, it's weird. I don't know. Angular max. What is max F? Oh. And then min. I have no clue if that's right. Maybe I just try it and see what happens. Yeah, that's what I thought would happen. I gotta take the dog out. I'll be right back. I'm back. Okay, so that wasn't right. Should it be over this times acceleration? No, because the minimum actually makes it a very large value. So that's actually not correct. Because if the difference is 0, that means it wants to move towards 0 now, I guess. One sec, dog's barking. I'm back. Okay. Oh my gosh. All right. Larger value between this and rotation minimum rate. And then the smaller value between it's just all right, maybe this helps. So what I said before was that when it has a degree to go, it's essentially going to take, due to this, it essentially means it will take a second to reach 0. But then after a small fraction of time, it is now like 0.8 degrees, and now it will take a second to reach 0 from 0.8 degrees. So what I'm doing is I'm interrupting that and I'm saying, and I'm putting a floor on that, so we say, all right, we've hit. Okay, so this should be state step. There should be that. All right, so there's that. Well, I shouldn't have to, okay. So I should not have to do that. Or do I? Because I'm technically multiplying it by step, but also not. Dog really wants to just bark right now. But then I have the issue where, yeah, when angular is 0, there. Okay, so there is a point. I know it at least starts at 0, where I do want 0 to be 0. Maybe it's angular times rotation acceleration? No. I know that 0 should be 0. Okay, but there's a point at which it flips between being like less than a degree per second. So I want to stay at a degree per second. And there's a point at which it gets so small that I say, that it has to stop. Should I just leave this? No, I don't think so. I think I need to figure this out. I think I really should figure this out. I guess I want it to be at the point where angular velocity needs to move towards 0 on this step. Right? That's kind of the idea. If my difference is 0, maybe this is the way that I think about it. If the difference between angular velocity and because this is kind of a difference, right? Oh no. This is just... Alright. I literally have to draw a number line, like I'm just totally not in it. Okay, number line. Alright, so here's where I'm at. Okay, here is where I want to be. My minimum... Okay, let me try that again with a vector layer. Number line. Here's where I am. Here is where I want to be. I guess I mean, maybe the real issue is that I'm treating angular as a target rotation rate per second, maybe that really is the problem. Because I want to say I want to move towards a maximum rotation rate with some acceleration. And then once I'm noticing that my angular velocity has reached that rate, I just leave it. And then once I'm at that cutoff point, I want to say, all right, so we have to move, we're currently rotating 2 degrees per second. And after this tick, I'm gonna overshoot. Like, I don't know what that really means. I really don't know what that means. So let me just keep with the diagram. All right, so this is my minimum step, okay? Minimum step. All right, so I do the step, I go forward, I do the step, I go okay, I'm gonna make this a little bit faster. We're over here, I make the step, and then I need to say, all right, so my minimum step is larger than, yeah, okay, I think I've actually cracked the problem. So it is because this is effectively targeting this rotation per second. So I could kind of think about this as looking like that. I can think of it looking more like this. This is a better way to look at it. Angular velocity move towards this angular velocity per second with this rate. I mean, who knows? What are the odds that even does anything? I mean, I think it should do nothing at all. Okay, it makes it really, really small. Okay, so it actually had a kind of a large effect, which I'm surprised by. Is that correct? Is that? I don't know. What if I did this? It's gonna be insane. It's gonna flip instantly. Okay, well, it's still technically doing the exact same thing. All right, well, that surprised me. I didn't expect to see that. So angular is a difference. It's purely in that sense a difference. I probably shouldn't use it as a rotation rate. What I should do is say, if my difference I mean, I guess really what I should be doing is saying, if this is positive, make it positive. If it's negative, make it negative, right? And it's in radians per second, so it'd be like, I have a rotation acceleration, then I have a rotation speed. Let me just say rotation rate. Typically your acceleration is a lot higher than your max. Like I might have a max speed of 3 when my acceleration is like 6. I mean, it's like exactly double. Wow. That was really hard for me to say all that. Maximum rotational speed when turning. let's say 90 degrees per second. I mean, honestly, I'll type in 180 here. And then I'll do 360 up here. And this can be 180. And this could probably be like 120. Maybe like 270. I'll use these values. These values seem right. So if I have a positive value, then I want to say oh, wait a second. Hang on, I'm doing a max. I'm actually doing that really wrong. So let me say angular sine multiplied by rotation rate. Okay. So now I expect to see it reach 120 degrees per second, which is almost a second to turn around, or a little bit longer than a second to turn around. It's going to flip around really fast, but then it's not going to be able to stop. Okay. So because I'm trying to look down, the pitch is kind of going crazy. So I'm just going to make that be 0. Or I can just do that. Roll, I'll leave roll. Well, roll shouldn't even do anything because it's not pitching anymore. Right. Maybe it should be even higher than that. Okay. Yeah, maybe it should be like 180. It can take us. It takes a second to turn around, which still seems quite slow, I think. I feel like a person can whip around in far less than a second. Okay. Hey, Marks20. Thanks for the follow. Okay, so it turns around, so I'm treating this as a target rate, but then I would say maybe this is where I do the min between angular. It's not like that, right? Okay, no, it overshot really bad. Okay. How are you? I'm alright. How are you? Hey, Danilin. Hominid? Back hard into deving. You're done with a castle? What game are you creating? I am making a robot shooting game. You're gonna shoot robots. And this is the most difficult thing that I'm making, so I'm making it first. And so far it's going well. He needs to be able to slow down though. Like that overshoot needs to be corrected really hard. But it does walk, and not right now. The red spheres and the green circles are where it wants to keep its feet, and you can kind of see that. Yeah, I know I messed him up though. So, or the smaller value between state dots angular. Think about that line. Think about that line. If I want to be at 0, okay, not even that. If my rotation rate is fast enough that I can cover angular in a single step, so my current angular velocity is that it? My current angular velocity is greater than the difference between these two in a single step? Maybe that's it. State dot angular velocity minus angular. I'm going to angular, and it's like the end minus start, right? Okay, but minimum is probably wrong still, because minimum means this could be negative, and if this value is negative, what do I call this? Do this. Okay. My guess is really like max rate. So move towards this at max. Move to max rate. Man, this is just what gets me. Like this part where I need it to not overshoot is really hard. It's whatever it is, it's just not intuitive, or I haven't done it enough times. Max stop speed is ground speed over this. Like that's it's different because this is me trying to stop at some desired rate. So either my maximum speed or this, and then stop friction is just applied somewhere? I add it to ground friction. Ground friction is put onto friction, and then that is multiplied by step. And then step is used up here. I can just ignore that. Step is up here. But I also have an acceleration. Okay, so my max rate can't be higher than what I would cover in a single step. If I think of it like that, I think that's probably as simple as it gets. Though it's not quite correct, I think, because acceleration is still not considered. I mean, maybe it's fine. So what do I expect to see? I think what I expect to see is that it will accelerate and then hard stop. But that won't really look good, right? That won't look good. So the sine times rotation rate, but then the max rate should be definitely something to do with Angular, but some like absolute value minimum thing. Maybe I just type it up and it'll work. Should be max. Nope. Nope. Max rate min between Angular sine. No. No. Gosh, I can't get it right. Oh, wow. I don't like it. I don't like it. Max rate is max rate min with absolute value min it's the fact that signs are that's what sucks. I think I'm just getting frustrated and I'm not going to figure it out. So I'll just leave it as Angular. And for now, I will also double it. I will quadruple it back. Okay, maybe that's a bit too much. Just might be. I mean, you know what? Maybe I can quadruple it. And then what I say is that if any of the legs are... They do this. If any leg is grounded, we reduce it. If either leg is effectively not moving and it's not comfortable, we cannot continue rotating on the Y. Okay? You know what? Did I even do anything? Did I even validate? I mean, I fixed the pitch thing. That is what I did. I did fix the pitch thing. Yeah. Rotation rate is nothing right now. Get rid of the cranking bit. Fix yaw to be independent of the current pitch. And then I'll figure that out later. What's different here? Yeah, fixed grid pitch thing. Okay. I feel like that, whatever that is, it's just gotta come to me when I'm literally not thinking about the problem. Like I need to let my mind wander on that. Okay. Fix crawler, yaw, rotation with pitch. Pretty much it. Yes, and not, whoops, nope. Try that again. Fix crawler, yaw, rotation with pitch, overshoot, add overshoot. So yaw is no longer affected by current pitch, which caused the pitch axis to change. Making it rotate further, making it pitch more than intended. And then multiply angular targets to create a bit of overshoot and help it reach target angle faster. Needs a rework to use max rates and have a tunable overshoot damping. Alright, that's the idea there. In the future. For now, I can't think of it. So I'm going to keep moving forward. Send that. Right. Compile days is now at 6. it's never gonna send is get down. Is get down. Maybe. Maybe. It seems like it's been reading higher than normal. Okay, so that's just never. What? What do you mean you finished? That's really weird. Okay, so it worked, but then it just never printed anything. So it just looked like it wasn't running, and I killed it, and then it said, oh yeah, we were done. I finished that. Okay. What's next? Fix leg rotations over time. I think okay, so before I do that, I need to fix rest positions not rotating with the body. I need to make that work. Okay, so what's that right now? I am debug displaying it. So this is the rest area, which is placing at the target global rest, which does use the current state transform origin, plus the... What? Should this be state.transform basis? Oh, there we go. I actually am shocked that that worked that way. That's weird. Really? So the rigid body has a different transform. That's crazy. Okay. Cool though. All right. And then I want to say, if my yaw, what? All right, so no yaw when this is true, blah. And then I say, and yaw is a difference as well. So I could do this. No yaw when any leg is stationary and uncomfortable. So that's what his does, and I think it looks good. So if, I guess for, well, I'll say all legs comfortable. True. I guess I could make this a method. I don't really need to. I don't know where else I'm going to use it yet. So if leg is not, whoops, not comfortable and is moving. And break. Okay. If all legs comfortable, then I can do this. Otherwise, yaw is just nothing. Do I use cosine theta anywhere else? No. Okay. So start with 0. No. And then I guess I actually have to do this as well. I have to. Oh, I guess I really do need that. Maybe what I can do is I can say, have like a boolean that's like a limit yaw, and I can just set this to true if this is true, and then if that's true, then I can check this, and then if this is true, then I turn on the limit. Maybe that's what I'm looking for. Okay. If all legs are comfortable, then I can do this, and if this is true, then I say restrict yaw is true. Same thing here. Restrict yaw is true. Then I would do this. Otherwise it's this. And then I need rotation for that. Rotation is actually used there and only there. I need it here to reduce that. And then I can do that. And then here, I guess I can say, reduce for each leg off the ground. Hey, pawn. Right, that is what he has. He just multiplies it by that value. He does a count. Well, actually, no. I don't do that. The yaw is just multiplied by that at the end. Or the acceleration is multiplied by this at the end. Like multiplier. This is a float. Then let's say and I guess I can do count grounded up here since I'm iterating through it already. You figured out the rotation issue? Nope. I give up on it for now. I think I need to... I think that Lily just needs to be a... It needs to be one of those things that I am not thinking about it at all, and then my subconscious just presents me with the solution, and I'm like, oh, let me try that. So, yeah, that's where I'm gonna leave it for now, because there's just something there that I'm not. I think what the issue is that I think I know how it should be, and that's not allowing me to actually think about the proper solution. Why are you pretending like this is unused? I don't understand. What's the problem there? Integer division. Of course. Now you're happy. All right. So it should... it's going to struggle, I think. It's actually going to struggle really hard to rotate towards me. Yeah. That's not what I expected to see. So what did I miss there? So we can't do yaw. And max acceleration is... I mean, I guess that actually does make sense. So perhaps the problem is that the ray casts don't go into the ground like they should be. So I guess I need to make that happen. They need to go into the ground a little bit. Oh, but they do. Wait, so why is it struggling? It's, okay. Oh, I think when it's rotating, it needs to treat it like it's moving. Opus supports 256 channels, making... What? Meaning, in an entire movie, each actor could have their own channel. Okay. Cool. I feel like those aren't quite related. Also, there's no way. The way it's worded, there's no way that a movie like has on average 256 actors. It's probably like 20 or less. Actors with lines, I guess. Okay, so why do we struggle? I think we struggle because this needs to like present itself as being in motion. So maybe the rest area... Dog. Okay, I gotta take the dog out. The solution here is definitely just to increase the rest area while it's rotating. So, I'll be right back. I'm back. I feel like I should, like, time my dog. Because this is definitely averaging, like, he needs to go out every 50 minutes in the morning. Or 40 minutes. Alright. Sorry I missed this. You would think left and right for each actor and would still have 200 something channels. What do you mean left and right for each actor? For effects and music and everything else. What's like the point? What are you getting at? I don't understand. This might as well be saying like a gallon has 64 cups or 128 cups or whatever the number is. That's enough to put a cup in every, like, a hole in the ground. Like, I don't understand what the connection is or what the point is. You could water 10 plants with that. Like, okay. I don't understand. What's your point? If you're trying to say it's a lot of channels, that's not a good. I think there's a better, like, way to say that's a lot of channels. Yeah, I'm smart. Alright, the legs need to have some way to know to increase their rest area. Their rest area size? Comfort distance. So it's a has desired forward. Or it's like trying to rotate. Yeah, let me say this. So let me say, let me have like another boolean or something. You know what? Let me just put it on. I'm kind of gonna drop that. I'm just gonna say body dot is stepping. We'll start it on true. Well, I'll start it on false, and then if it wants to do something, then it will do something. I mean, what I would really say is probably do like what? If has desired forward is stepping is true. And then down here, I'll say okay. Who uses has desired forward? Who uses that? Because I might just need to like totally remove that. Leg, character controller. You know what? Let me say has desired forward is going to be a get, and it returns exactly this. It returns desired speed and not desired direction. Okay? I'm just going to say that. Because it's getting dumb. This is getting dumb. Some of these order things are getting dumb. Okay. Now, our leg, if we are stepping or body as desired forward. Let me say this. Is stepping will be that, or instead of update rotation, I will have just more booleans. I don't know, I just need more booleans. Yet. I really don't like doing this, but I don't know, it's getting out of hand. I just want it to work. No, okay, let me make it correct. Character controller does not handle rigid body rotation. It specifically does not do that. It does not do rigid body rotation. So it makes sense to have this here. This is not like that. It would be false. And then down here at the bottom, if this is approximately 0, if this, and then I say else, as our rotation is true, as our rotation is false, I mean, I guess I can write it like this. It's a bit better, right? After go through all of this, if I want to do something, then I say that. And maybe I would actually like to say desired direction or target. Wait. Target position infinity is finite. Goal forward. I'll say this. I can pretty much just do this right up here. I can say I can do cosine theta immediately. And if this value has desired rotation is equal to cosine theta is let me say like what's a degree? One times 180 over pi. Pi over 180. 99996. Okay. Whoa. All right. That was really difficult for it to figure out. Okay. And this is supposed to be like this, actually. It is getting so lost. What is it doing? What is it doing? How did this happen? Literally, how did that happen? How did that happen? Is this, do I just, maybe just less? When does it think it's done? It never thinks it's done. It can never align itself to me. Huh? How does that work? How does that work? It's in range. What? It's instantly in range. It doesn't. What? Oh, because checking is stepping. Wait, what? Is stepping is just a return. Get. Has desired forward or has desired rotation. Has desired forward. I mean, it is just that this is never being zeroed again, because this gets to the value that I'm looking for and then it stops. So has desired forward is not getting zeroed, is what's happening. it's not getting reset. If target position is finite, and the difference between target position and my position is more than 2 meters. Oh, but desired direction and speed is never being set, so it's always false. So it must just be that this is... It's false, but then that doesn't go down. Yeah, I don't understand what that's about. This becomes true and then it never becomes false. It's never false now. It's just never false. So it's true because of why. As desired forward is false. This is what I don't get. It says turn. We want to turn. So you're stupid. So it's stupid. What? We're going out, going to take pictures of people in public places. Okay, cool. What is going on? I'm so annoyed by this. I'm guessing it just becomes true and it stays true and it never stops being true. False. I saw it. Huh? Why? How is angular true here? How does this have anything? Okay, well I know it's the turn. As desired rotation is being left true somehow. It's this very tiny value. Okay. So it is this small value. Perhaps what I mean to say is that the length squared. Yeah, I think that's the problem. Is that the length squared of this should be checked instead of that. Okay. I won't, well, I will give it a, I will make it a constant. Okay. No, technically it should also fall to the ground, I guess. That will help it in by not doing these insane overshoots. So, because I'm pretty sure if I make it turn around, it's just gonna like freak out and go flying. It struggles. Yeah, okay. I mean, it could also just have like a really high, this could be too high. The rotation acceleration could be too high. I don't know. I'll just drop it a little bit. I'll just drop it a bit. I have to reset all of these. Because that may just be an actual problem. It may be really struggling to... Huh. Okay, so what's the problem with that? If I'm at just the right angle, it kind of like... does that, right? So what's the mistake there? It probably is just some of these values are too high, right? The acceleration might be too high. Still. I mean, maybe this shouldn't be, I don't know. Let's just make it 1.5. Why not? Okay, so I'm expecting this is just, yeah, okay. I mean, there's also probably the fact that if a leg is uncomfortable, it probably applies a lot of... Well, okay. It's also that while legs are in contact with the ground, they can... Let me say this. Let me not say is comfortable. Let me just say if it's grounded, it can act, it can do something. Maybe that's probably the problem. That probably is. That probably was it. Because they can still like apply friction, but it doesn't want to rotate too fast. All right, that was kind of it. Yeah, just if it's grounded, it can technically do something. Right. Maybe bring this back to 4. Maybe this is okay now. Look at me. And it did some... Oh, hello. Alright. Funny. What is wrong with it? Why can't it... Okay, so 4 might just be too high. 4 might just be too much for it. That's funny, it put its leg on my camera. I was not expecting that. Okay, so yeah, it looks like the pitch is now kind of having a problem again. Why is the pitch having a problem again? I thought I just fixed that. Wait, what? This is supposed to be pi minus yaw over pi. So when yaw is 0, this is pi minus 0 over pi. When yaw is pi, this is pi minus pi, 0 over pi. Well, that was... okay, that would explain that. That would actually perfectly explain what was going on with it, like, flipping itself over like crazy. Okay, so I probably can do times 4 now, probably. Though, you know, perhaps it's just a bit too much. Okay, so yeah, times 4 probably is just a little bit too much. Let's do 2.5. Oh, I can't believe I made that mistake. Look over here. Awesome. Look over here. Look up here. And it broke. Okay. So pitch went insane again. So is this meant to be abs? That's probably what this is meant to be. Probably. If I can just do math correctly. Look over here. Okay, so it's okay. Why? Why do you do this? Look over here. Okay, so it says it keeps wanting to rotate up 0.2. Huh. Interesting. So somehow... no, that does need to be basis y. Goal forward, cross with this gets me a left axis, technically. So pitch says 0.2 and it never goes down. Why is it still wrong? Okay, so it's 0.2 there. So what is it before it reaches that multiplier? It's 0.2. Okay. What? It's 0.2 instantly. Okay, well, I mean, that's just where it wants to go, right? Okay, so what about before the limit? Yeah, okay, so it just keeps reading a higher and higher value, so it's definitely incorrect somewhere around here. I hate this. Why is it doing this? Is it from here? It should always be from here. Okay, so what happens there? Maybe if I stand in front of it, maybe it does it. Your legs are not on the ground. Those legs are also not on the ground. What? That's weird. So the value should be reading 1.57 pretty much always, right? Okay. So what happens when I do this? Alright, so it's reading a very, very tiny value, which means a huge up, which is, so this is just wrong. Am I ever gonna get pitch correct? Is that ever gonna happen? Okay, so pitch needs to be the difference between, I guess like the opposite difference. Well, no, yeah, the angle between my current y-axis, I guess, and the desired y-axis. That's kind of what I'm really looking for. Along that pitch angle. So essentially what I can think of is saying my current y-axis this goal forward could actually be my goal up. So if I take my goal forward, I cross with my ground. No. If I take my goal forward, I could do this. Take my goal forward. So what's my desired up axis look like? I mean, it's essentially the angle between my goals, its own up axis, and my ground normal. Or my up axis. Could do it similar to this one. Go forward sign to angle 2. On the down axis. Could I not do it the exact same way? Why am I using down? That doesn't seem right. That doesn't seem right. Because what if I'm upside down? Oh man. It's too much rotation. It's way too much. Too much for me to keep in my head. Why is that vector down and why is that vector up? Those aren't right. That's not right. I think this is probably this could be part of the issue. This goal forward is being rotated incorrectly. Which, first of all, this should... Looking from Not really from my up axis, but I guess looking from my up axis, right? Like this should just be state transform basis y. It should just be that. The problem is definitely that... Okay, let me bring this back. Pitch is 0. Yeah, okay. Let's start with getting y'all correct. Because, I mean, I have it in a weird way. So the value increases as it gets closer, is the weird part. The value is increasing. Okay, funny. So this is what I don't get. Goal forward, signed angle to this. Why is this wrong? Why is this already wrong? Because if I think about it like this is the up, right? So it reads at positive 15, negative 15, right? From here. Maybe it's more that this should be forward signed angle to that. Looking from... Fine, I'll just make it that because it's just stupid. It is just really stupid. Okay. And then apparently it never quite gets there. Okay. Huh? What? How does it never get there? How are you never getting there? Oh, let's do tangent. One more. Okay, so now it says it wants to go that far, and then it wants to go the opposite direction immediately. Alright, so strangely, that's just a bug, I guess. Why does it flip? Maybe what I've really meant to do is have this assigned angle to go forward using my up axis. And that's what I really meant to be trying. And then it starts doing that again. Okay. I don't understand. Why that happens. I mean, it's possibly related to this. Let me see what this value is. .6 degrees. Yeah. What? Why is it doing this? Is it, this? No, because it clearly is actually rotating. Oh, maybe I'm looking for if any of these are more than, not the full length, but if any of these values. No, because it would all add together. This is if they're off by more than half a degree. Okay, I think what I really mean to say is that this 0.00 if it's greater than 0.0017. Be serious. Huh? What? The circles are never getting larger. Right. It is still stuck. Doing this rotation stuff. What is it doing? How does this happen? Why am I getting the same number like 3 times and then it's the opposite number 3 times? What's up with that? What does that print even? That's the yaw. So it wants to rotate, and then it just doesn't? This was still happening here. Yeah. When did this bug happen? What? When did this happen? What did I'm mad. This is just too much garbage. What happened? What did I even do? I removed has desired forward from there. That's just nothing. Pitch is just zeroing. Leg multiplier. If angular is 0, and then we're really small, we do that. Is that the problem? Angular should be... What? What? Like, is it running twice? Somehow? I don't know. Is this running twice? Let me try this. What? In a single step, it says we want to go 5 degrees. Oh no, we want to go 5 degrees the other way. No, huh? What is that? Why is it negative now? It wants to go forward 5. It wants to go back 5. Forward 5. Back 5. But then it's doing this like several ticks in a row. What? Huh? That doesn't make any sense. What is happening? That really doesn't make any sense. Is it because I'm not moving the pitch anymore? Is that actually the problem? Because I'm not moving the pitch? They can't align. What the hell? My goal just moved, like, dramatically. Wait, why is my goal changing? Why did my goal just change there? Why did the goal change? Wait, why is the goal changing? Why the hell is the goal changing? The I see the goal. I saw the goal change again. 8.282. Wait, what? Okay, first of all, how is the goal... Oh, I guess the goal changes because of the restrict Y. I guess that's what happens. So if I have my rotation is my forward rotating the goal. So what I want to do is I want to take the goal and I want to rotate the opposite of that when I restrict Y. That's probably the first thing. Should probably go the other, we want to rotate it back, right? Okay, first of all, I don't know how this could be wrong. This one just can't be wrong. Y'all should probably just be negative. And then if it's too far, then I rotate it. So to reach goal from my current one is like plus 20 degrees. I'm going to say, all right, well, I can't do that. So let's take the goal and rotate it to that point. Okay. Otherwise, my yaw is going to be the opposite of that. Right. We want to rotate the other direction. Okay. So what's changing? What's the difference between these two? This value got a little bit closer. Oh no, this value went over. So we rotated too far. Which is just like, I don't even understand how, but okay. I mean, maybe this is where over-rotation needs to come in, because if Why is this happening? I think it's happening because I am over-rotating. So even here, I'm below, right? 3844. And then I'm above, 3845. So I've overspun. I mean, I flipped signs, basically. I was above it here. I'm actually still above it here, but this one changed. I was below it here, and then I'm above it here. So sure. Right. I'm not even skipping a step either. I'm not going to like, all right, let's zero angular velocity. Right. That's not happening. I mean, I can also say that once I'm within a degree, I want to stay where I'm at. I can also just say that. Which I think is what my idea was up here. Once I'm within a degree, I stay there. I'm also thinking the state step is probably wrong. I want to print out. I want to print this. No, it's actually still fine. Okay, never mind. I do something else. I'm actually just so annoyed with this right now. Okay, I'm gonna go get food. I'll be back. I'm back. I've got food and I'm going to eat. Also, my headphones arrived, so I'll be opening those up once I'm done. Oh man, I'm just in a sour mood. I think what gets me is that I start messing with things to try and, like, you know, dial in some problem, and then a new problem appears that is not really that hard to figure out what the issue is. The issue is definitely probably related to the fact that my desired angle is pitched and I can't pitch. It's probably part of it. It's just yeah. Really what I should probably do is set target direction, or like target position. I should probably be doing that. That would probably help. Yeah. I mean, it's actually technically still wiggling, which is a bit annoying. How is it wiggling? Is it? It's not wiggling. It wants to rotate a little bit more, but it just can't get there. But that's, at least it's not wiggling now. Okay, I'm gonna eat. I'll be back. I'm back. All right. Headphones. The box. I'm opening it. Hopefully, I don't pull these out and they crumble in my hands instantly. That would be probably the worst outcome. Nice. Interesting. What is that? There's this weird thing on the inside. I'm not sure what this is supposed to be. If I can even show that. Kind of see it. This. Right there. There's a bump. Weird. maybe it does not come out. Okay. So it definitely does come out. Or not. Wait, is it like... Oh. I'm trying to break it. That's what I'm trying to do. There's like a locking thing. You have to twist it to pull it out. Okay, good. Because I have to pull it out because that is a very large cord. I need a small cord. And then it's locked. Okay. Hello. I can hear myself. Great. It's really quiet too. That's great. Oh man. Headphones again. It sounds weird. It sounds like I'm in a radio. At least my own voice sounds that way. But I'm guessing that's just because I can't hear myself very well. That's my thought, at least. It is just my own voice though. The music sounds fine. I guess I'll find out as I listen to more stuff. What is this? I don't know what this is. There's just a button here. I don't know what the button does. I don't think it's a microphone. Oh, it is. Well, who knows if it's on or not. Because it doesn't pick it up anyway. Okay. I mean, is it? Alright, it just does nothing. Well, not that it does nothing, it just doesn't go through my Microphone does not care about it. Alright, so I want to know when this happened. Because I very quickly built up some slight rotation here. This is my current forward, right? Yeah, this is my forward. So my forward pitches down. I'm assuming that's just from roll. So I suppose I should also make roll be 0. Run this again. Okay. Now it is just looking at me. Okay. Every time I add anything, it needs to work the same. Okay, and then we're less than like 0.1 degree, which I think is somewhere around, yeah. When we're about 0.1 degree, we don't want to turn. All right, but I think this is wrong. I think this is wrong. What I should instead be doing is allowing angular to happen, but I want to specifically say if target is finite. Okay, so here's what I do. What I want to do. I want to, oops. I want to go here. I want to say, I'll do the cosine theta up here. All right, I want to do if if the target direction dot, okay, not, okay, no, nope. Here's the difference. My pitch, my target direction can be straight up, but my maximum pitch is like 12 degrees or something. So when I hit that, I want to say, okay, I'm not turning anymore. Or actually, I guess it's really about yaw, isn't it? Oh, it's only about yaw. So is rotating should actually just be if yaw is greater than some value. In fact, that's actually it. That is it. So I want to say has desired rotation is equal to rotation being greater than, I guess the absolute value of rotation being greater than approximately 1 degree. I'll say 0.5. If I want to turn more than half a degree, then I am... do this. So 0.0087. You know what, let me just say it's if it's more than 1 degree, actually. If it's more than 1 degree, 174. And then that's all I do for that. And this will go back to angular is 0 approx. Okay. Look at me. Awesome. And then it stabilizes. Why is it not stopping? Or did it stop and it was just... Whatever. I can fix that later. Okay. All right, so this is working, right? Also, I can really do this up at the top, honestly. Yeah, and you know what? Let me make this actual yaw. I can just put this in here. Because rotation is not used. I mean, I shouldn't be using it anywhere else. Yeah. Go up there. Okay. However, I think what this should be is I want the yaw to rotate looking down from my the rotation axis is actually going to be the ground normal. That's what it's really going to be. It's going to be the ground normal. Yeah, I even do it here, where the yaw is applying on the ground normal axis. So that's what I really want. I want ground normal. XZ dot. So xz dot is the radius. So this is the distance, effectively supposed to be the distance from yeah. It should be this. Cosine theta, however, maybe I should set something up here where I say I have a preferred basis. The preferred basis is effectively this. Sort of. New forward, right, cross up. What? Right, cross up gives me a negative, which is literally a forward, right? So my current right, okay, I think what I really have is an ideal right. Or, okay, first of all, all right, let me think about this. So I think he actually mentions this where he constructs his forward and his right using he says it like right here.
Now that the spider has a visible body, it looks odd that it can only rotate on one axis. To support 3 degrees of rotation, I rewrote the plugin using quaternions, as they tend to be easier to work with than Euler angles. To calculate the target orientation, I take the vector between the front and back legs and use it to calculate the pitch. Likewise, I take the vector between the left and right pairs and use that for the roll.
Right. So I can think of it like this. I can I do it this way, where I just have that vector is my forward vector, so my feet is my forward vector, my ideal forward. And then my right is that plane of the legs. I cross those two. I get my ideal up vector, which is going to be the orientation that the body wants to point, right? It wants to point up towards whatever that is. So it's like that's like my preferred angles, right? I want yeah, I think I want the body, which affects the whole thing, to have that sort of orientation, right? Okay. What? This might be good to look at. Let me find it. It's probably this one. Yes.
Better. This variable to the top by our offset. Finally, update other functions and using the difference to calculate.
Wait, what is this? Angle to point?
Rotations on the relevant axis. This method works great until you go upside down or vertical, and then it quickly falls apart.
Oh, okay. Never.
I had to come up with a solution that would work for any orientation, and that's when I remembered my old friend the plane class. A plane is essentially a position and a direction, also known as a normal, that has various uses. One way we can initialize a plane is by putting in 3 positions in a clockwise order. My idea was to create 2 planes from the IK target positions, then we can average the normal to get our body's desired orientation.
Can I do that in a simpler, or I guess, yeah, just a simpler way, without using plane? I mean, I guess that's encoding the full... I guess it is encoding the full pitch and roll in one go. So... I mean, I think I can... I mean, if I take... Okay, if I take... the average vector between all rows of legs. I could even just do the front and back. That's probably not what I really want to do. Well, I mean, what does... Whoops. When he shows it, it sounds a bit wrong to me. In fact, it kind of looks wrong, because it looks like this vector does not match the actual vector. So probably what I mean to say is that I should orient the forward by the back to front legs, ignoring the ones in the middle. And then the side would just be all of the legs. Or I guess maybe just the front and back legs only. Sure, I'll do that. And those will give me the actual vectors I want to have once I can get to fix the window. Also needed to open the door. It got very hot yesterday. Today it's supposed to be warmer, probably. Okay. So if my target direction is finite, then I want to keep looking where I'm currently looking. That's not exactly true, right? So I will have a goal forward. I'll just have a goal orientation, actually. I'll do a full orientation. Okay. So my goal forward is either where I'm currently looking or computing the forward from my back to my front legs. And then goal, I guess I can put this down here. Because goal right will be influenced a little bit by goal forward, I think. Like pitch stuff. Wait. This, okay. So here's the thing about this. I really only need a forward and an up, or a forward and a right, and then I get the other one. I don't have to make all three of them. So I'll say my goal right instead, and that's going to be my roll, effectively. Yes, that's the direction that, you know, if I think about my fist being my head and this is my right vector, that's the roll, right? Whichever way this points dictates the roll of my head. So, and then a forward is just exactly where I'm looking, which actually just encodes everything. That's either going to be my target direction with some limitations for pitch and yeah, pretty much that. It'll have limitation. I'll put a limitation on goal forward for pitch. That's probably what I should do. After I compute my goal right, then I will have my pitch. I'll be able to figure out what the pitch can be from that right angle. Okay? So goal forward will be essentially the average of both sets of the front left and the front right with the back left and back right legs. So yeah. What do I pick here? Do I pick where the lake currently is? is this? What does the leg have? Is grounded. Target rest position. I'm looking for target rest position or target global rest. I'm probably looking for target global rest. It should be not that. It should be where the leg is. Or next step target. Step target. Step target doesn't move. It is just where it wants to put the leg. And it's constantly being updated. Okay. Okay, so if all of these are finite, then my goal forward is that. If any of these aren't available, my goal forward is my current forward, I think. Yeah. What does it start as? It should start as infinite. Yeah. How many times did I hit enter? That was 3 enters, by the way. I had to hit enter 3 times there to get to the next line. It was so stupid sometimes. It really is. End minus start. Wait. No, this. What is this? Is it, yeah, that's right. Okay. Gotta go forward now. Now, my goal right is always going to be no further than some number of degrees off from my ideal right. Do I? I don't think I can write that because it's not like code. I mean, I guess it's actually all up here. So my right vector, looking from this way, is actually right minus left. And that's my right vector. All right. Maybe I actually should change this. Preferred right. That's a better name. Because my actual goal right is different. My goal right is going to be based on this one. So what I can say is, given I still want to get like the actual pitch, I guess. So I'm still doing something like this. I'll move this all the way up here, so because this is what I'm working on right now. So my pitch still needs to be something like, I'll just ignore that. Go forward, cross that. So I'm doing is I'm taking my goal forward. I am I think probably what I should do is, given my goal forward with my goal forward. So I kind of get the wrong direction for my right axis. It would be negative if I do this. Well, actually, no, not really. It gets me... Well, no, it actually is wrong. It is kind of flipped. So... if I were to... I guess essentially... Oh, man, what am I trying to think of? What am I thinking of? I could say this. No, I can't say that because I have. Sorry. I have a particular. I have this thing where the, where for things above but a little bit behind me, I don't turn. But I will look up. I will still pitch up to meet it. So essentially what I want to say is... I mean, yeah, I kind of want always... wherever I'm currently looking, to know what pitch I should be at when I'm done rotating, I would first have to pretend to have rotated all the way and then matched my yaw and then looked at it, right? So that's... maybe I need to do that first. So let me move this up. After I get my goal forward. So pretending that I have rotated no. I hate it. Everything depends on everything. Everything depends on everything. What is happening? I think I need to start over. I think I actually really badly need to start over because there's too much garbage happening. Too much garbage. None of these are particularly complicated. It's just doing like very simple clamps, very simple signed angle to. There's that, but that's like whatever, right? I'm going to remember this. Okay, I don't need to remember that one. But I do need to remember that one. And I'm sick of it. I'm literally gonna start over. I'm so done with this. I think I want to keep those. No, I'm literally I'm so actually destroy it all. Literally destroy it all. Some of this stuff I definitely will be keeping, like these things. Angular is still going to be essentially computed from a pitch and a roll. I hate it. I hate it so much. I hate it so much. I can't. Okay. You know what? Today's just not a good day. Today's not a good day. Today's not a good day. So I'm going to stop there. I'm getting so frustrated with this. None of it's clicking for me, and that's making me mad. And then I can't just do what I think should be simple reasoning on how to use this information. I have a preferred right angle. What does that mean? I literally don't know. I don't know when, you know, I don't know anything. I actually gotta stop. All right. That's it for today. I'll try again tomorrow. Goodbye.